Hi there, welcome back to The Logic of Risk. I hope the little break gave you a chance to catch up on past episodes, or at least to forget about yours truly for a while. But good things never last forever, so here I am again with episode 17. In the last few weeks, we have talked about random variables and the key functions we use to describe them: the CDF, the PDF, the quantile function, and the survival function. If those words don't sound familiar, I strongly suggest you listen to what we have already covered. Very briefly, a random variable is one that can take different values, each with a given probability, depending on which random event occurs. Those random events are exactly the ones described by the probability space omega fp. We also just touched, on the loss space RBPX, but we said we would save the deep dive for later. Today, I want to tackle a distinction that's crucial for anyone interested in risk and, as we will see in the tales of distributions, the difference between an extreme and an outlier. Let's start with outliers. Outlier is obviously an English word, and the English helps us define it. It comes from the verb to lie and the adverb out. So, an outlier is something that lies outside something else. Outside what, exactly? Easy. Outside the support. Remember the support? We defined it as the set of values a random variable can take. To be precise, it's the set of values the variable can take with positive probability in the discrete case, or where the density is positive in the continuous case. In plain language, an outlier is a value our random variable cannot take. It's impossible for us because it's not in the support. I can't roll a 7 when I toss a single six-sided die. 7 simply isn't in the support. 1, 2, 3, 4, 5, 6. What about an extreme? An extreme is a value we observe rarely, sometimes very, very rarely, almost never, and it stands out because of its magnitude, very large, a maximum, or very small, a minimum. If we want to be picky, there are also rare events that are only rare, with no particular magnitude, situations where the outcomes of our random variable are not dimensional quantities like weight or height, but rather things such as certain genetic mutations. We will come back to those when needed. For now, let's stick to extremes and outliers. So, an extreme is rare, super rare maybe, but possible. An outlier is not. And carve that not in your mind in letters the size of a house, please. Example: a guy who is 2.3 meters tall, about 7 feet 6 inches for our American friends, is an extreme, not an outlier. How do we know? Well, we have seen people up to Robert Wadlow's 2.72 meters, that is an astonishing 8 feet 11 inches, and we have seen Chandra Bahadur Danji, who died at 76 and was 54.6 centimeters tall, just 1 foot 9.5 inches tall, so 2.3 meters is absolutely possible. In fact, medicine and biology tell us that, in theory, reaching 3 meters, maybe a bit more, isn't out of the question. At the other end, human physiology can cope with heights down to roughly 40 centimeters. If I found a dataset with a girl listed at 6 meters, about 19 feet 8 inches, that would be an outlier, because such a height is impossible for a human. Why does the distinction matter? Simple. Statistically, an outlier is an error, and we treat it as such. If you can correct it, do. Otherwise, Throw it out and don't include it in your analysis. Example, still on height. If my data say Mary is 169 meters tall, I can assume it is a typo and fix it to 1.69 meters. The corrected value looks perfectly legit, so it won't skew our analysis. Or suppose I'm analyzing a city's temperature at 2 p.m. Monday 23 Celsius degrees, 73 for friends in the US. Tuesday 72 Celsius degrees, 161 Fahrenheit. Wednesday 26 Celsius degrees. At 72 Celsius degrees, the townsfolk would be slow cooked. Great for a pot roast or pulled pork, not so great for humans. So 72 is clearly an error. What do we do? Maybe it is another typo and we flip the digits to 27 Celsius degrees. Or we use a common time series trick. Replace 72 with the average of its two closest neighbors, the one between 23 and 26, that is 24.5 Celsius degrees. In short, we either correct or remove an outlier. An extreme, on the other hand, stays and we study it. Try removing it and I won't talk to you anymore. You have exactly two options. Analyze it together with all the other observations, or analyze it separately, only among extremes. But never, ever delete or fix it. Here is the takeaway. There are statistical methods to flag extremes and partly outliers, but the best way to tell them apart is to know the phenomenon you are studying. If you are not an expert, ask one. It's simple and amazingly effective. When I recently worked on a cancer report, I handled most of the quantitative analysis, but I'm not an oncologist. I'm a statistician, so I discussed every single result with domain experts. To me, the number 3 is just a 3. To an oncologist, it can mean much more when we are talking about a certain tumor characteristics. They might tell me that my 3 makes no sense and push me to recheck everything. Humility. Humility is key. Notice too that what counts as extreme often depends on context. A 2.10 meters, 6 feet 11 inches man is extreme in the general population, but far less so if I focus on basketball players. Once again, you must know the phenomenon you are analyzing. Also beware, sometimes we label a datum an outlier rather than an extreme simply because we are wearing blinders. Maybe we are using a wrong model that doesn't allow certain values. Remember historical bias? If my model assumes the maximum loss of my portfolio can't exceed the worst I've seen in the past 5 years, I'm manufacturing a flood of outliers all by myself. Don't laugh. Plenty of financial models do exactly that, unfortunately. The reverse can happen too. What looks like an extreme could be just a temporary illusion caused by lack of data. In a few episodes, when we talk about black swans, we will see that sometimes a black swan is simply an event we thought impossible because we were using the wrong support. But let's not get ahead of ourselves. Still, let me give you a quick example. Think of the pandemic. In April and May 2020, after Italy had been battered by the first wave, a bunch of learned nitwits in Europe produced graphs showing France, the Netherlands, Germany way down with far fewer cases and deaths than Italy. Some even called Italy an outlier, broadcasting their cluelessness loud and clear. How can you call outlier a value that has been observed and verified? I get their reasoning. Their cute little regression model fits almost every country except Italy. Therefore, Italy is an outlier. Right, so reality must adapt to their model. not the other way around. Yours truly and a few others kept repeating in vain, "It is not an outlier, and probably it is not even an extreme," as some more sensible people claimed. In the end, Italy turned out to be neither outlier, it couldn't be, nor extreme. Other countries caught up and sometimes surpassed it. In risk management, downgrading an extreme to outlier and maybe ignoring it is fatal. No observation, especially an unusual one, should be dropped or fixed unless you really know what you are doing. Distinguishing extremes and outliers is pretty easy when our variable x can take only a limited range of values and natural barriers exist. Height again, bounded between, say, 40 centimeters and 3 meters. Values outside that interval are automatically outliers. Values that approach 40 centimeters or 3 meters from inside are extremes. That doesn't mean they shouldn't be verified. Unusual observations are always worth double-checking because of their height information value. Things get trickier when no finite upper or lower limit exists and x can wander toward plus or minus infinity. Then domain knowledge is crucial, so ask for help if you are not an expert and always keep open the possibility that you are wrong. We will talk about all these in detail very soon. In the next episode, we will start discussing moments, the mean, the variance, and all their assorted friends. Moments constitute an important family of risk measures. They are fundamental, but as usual, you have to know how to use them. With moments, we can say a lot about our random variable x. We just want to avoid talking nonsense. Even if you have studied statistics, I'm sure I can give you an alternative angle you will find interesting. See you soon. Ciao ciao!